On page 491, I would like to start with 119 on 491, and let's read it. Students in a psychology class, I know you can't really read it, but you know, at least I'm showing you where it is. Students in a psychology class took a final examination. As part of an experiment to see how much of the course content they remembered over time, they took equivalent forms of the exam in monthly intervals thereafter. The average score for the group, F of T, now at this point I have to take notes. F of T, average score for the class, is 88 minus 15 natural log in parentheses T plus 1. After T months, so T in months. Okay. Part A. What was the score, the average score on the original? Original, initial, at the beginning. All these mean the same thing. And then in part B, they want what was the average score after 2 months, 4 months, 6 months, 8 months, 10 months, and 12 months. And then sketch the graph and describe what the graph indicates in terms of the material retained. Okay, so this is very clear. I'm going to create a table. The table will be T and F of T. But I can't start a table before you tell me what does this mean. What am I asked when I'm asked to determine what was the original?
The score of the test the first time they took it?
Yes. When the time was?
0.
Exactly. 0 months after they finished the course. And then 2 months, 4 months, and so on and so forth. So 0, 2, 4, 6, 8, 10, and 12. Of course, I'm not going to do this 7 times. I'm going to take my calculator if I find it. Yes, I did. And go to y equals clear whatever you have. Punch in this function, 88 minus 15 natural log. Oh, we don't have a t in the calculator, but we have x plus 1. And after I punch in the graphing calculator the function, I go to second and table and plug this in one after the other, sequentially. So I have 0, and 2, and 4, and 6, and 8, and 10, and 12. I don't want to repeat this 12 times, 10 times, whatever, 7, 2, 4, 6, yeah. So for 0 is 88%. For 2, I'm going to round it to 72%. For 4, I'm going to round it to 64. For 6, I'm going to round it up to 59. For 8, 55. For 10, 52. And for 12, I'm going to say 50. That is the easiest thing to do than to recreate the calculation or redo it 7 times. Any questions so far? Final question, we are asked to graph this. Any questions? Okay, so let's graph the function. These 2 types of paper are different, and that's why they don't cooperate at all. Okay, so let's graph. 0, 2, 4, 6, 8, 10, 12. T. Now, I see that the smallest is 50 and the highest is 88, so I'm going to just break the graph, or the y-axis, and say this is my 50, and this is my 60, and this is my 70, and this is my 80, and this is my 90. And this is, of course, f of t. And I plot the points now. 0, 88, 2, 72, 4, 64, 6, 59, 8, 55, 10, 52, and 50. I'm going to graph, and this is f of t equals 88 minus 15 natural log t plus 1. So what can you say about this? What is the trend?
Scores are decreasing.
Yes. So what we know today, and we score 88% in a year from now, if our knowledge still follows this pattern, we will only know 50% of the 12 months from what we knew. 88% initially, and we should have known 100% initially, but it didn't come out like that. So apparently, even if we learned something very well in that psychology class, they learned as much as they could, but still the maximum score, average score, was 88. Okay, this was an example of a log function, natural log. What is the base of natural log? I don't see a base. Yes, it's right here. Natural log and e, they are together. That's why they are on the same key. Both have the same base. The same thing with common log and exponential. Common exponential. They have the same base. Okay, next problem. Let's also look at 116. And then we made Ben wait long enough. We're going to start 4.3. The function blah 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 models the husband's weekly housework. So this is based on some data that they collected. So the function, I'm going to copy it in a minute, models the husband's weekly housework hours, f of x is the number of hours, x years after 1964. So what is x for 1964?
0.
0, excellent. Use the function to find the number of weekly housework hours for husbands in 2010. Round to the nearest blah blah blah. Use the function to predict what happens in 2025. So now I'm ready to copy down the information. So this is 116 on page 491. They are giving us the function, and this is hours. And always take notes when you read the problem, always. So we have 1.8 natural log x plus 3.42 x number of years since 1964, which makes 1964 x equals 0. So in part A, they're asking what happened in 2010, and then in part B, what potentially could happen in 2025, assuming the model still holds. I don't know. I don't know if it holds. But we assume it does. So, what does this represent, and what does this represent? The first one is x equals. If 1964 represents x equals 0, then 2010 represents x equals,
46.
Very good. And the other one, plus 15, is it 61?
That's just the one.
Okay, perfect. So all I'm asked to determine is f of 46 and f of 61. Of course, I'm not going to do this twice, because it's easier if I just put the function in, 1.8 natural log x, close the parenthesis, plus 3.42. After I enter the function, then second and table, and all I need is 46, enter, and 61, enter. So the first one is 10 point, I'm checking 1.8 natural log plus 3.42. Okay, very good. So the first one is 10.3 hours, and the other one is 10.8. 10.8 hours. Any questions? Any questions? Okay, moving on to 4.3. In 4.3, we are going to look at 3 properties of the log function. Only this function, log function, has these properties. 4.3, properties of log. Only log has these. Number 1 is the product rule. What does that mean? When we apply log in any base, let's say base A, to a product, I use 2 factors, but I can have 3, 4, as many factors as you want. So as long as we have a product, log applied to a product of 2 factors or more, then we will get the sum of log of x plus log of y. As an example, if I have log base 10, common log, of 2x, I can write log base 10, common log 2, plus common log x, because this is a product. Similarly, the quotient rule. Now, instead of a product, I have a ratio. Log base A of x over y. Do we have a wild guess what could happen here?
Log AX minus log of y.
Exactly the same. Log of the numerator, very good, minus log of the denominator. I meant to write y. Okay, here's an example. Let's say log of 2/3. This is the same with log of 2 minus log of 3. Finally, there is one more property, which is the power rule. The power rule is when log is applied to x raised to a power. Any quantity, doesn't have to be just x, it could be anything raised to a power. That power comes down as a factor, meaning it multiplies log. Do not confuse it or change it into a sum or anything else. It has to be a product. So when I bring something from the power in front, then I have to multiply by log. Now, all these rules go back and forth. What does that mean? If I'm given the sum of 2 logs, it comes from this. I can condense it into this. If I'm given log of a product, I can expand it into 2 logs. Same thing with the quotient rule. So if I'm given a difference of 2 logs in the same base, I can condense it into log base A of x over y. If I'm given log base A of x over y, I can expand it into the difference of logs. Now with the power rule, the same thing. If I see this, I know the number in front of log that multiplies log comes from the power of x. So again, this goes back and forth. If I have this, I can come up with that, and vice versa. One other, I wouldn't call it property, I wouldn't call it a rule, I would call it just a formula. It's called the change of base formula. Why would I want to change the base? So let's suppose I want to determine log base 3 of 9. I don't have a problem with this because I know I can change it into an exponential equation. Always remember, the base raised to this number equals this. And there is no problem. I know the number. It must be 2. How come? Because only 3 squared is 9. But if you ask me, for example, log base 3 of 7, I would say, no problem. I will change it into 3 raised to y equals 7. But if you ask me to solve this, I'll say no clue. I have no idea. I know it cannot be 2 because with power 2 it will be 9. But I don't know exactly what it could be. It has to be between 1 and 2, but I cannot come up with this. So is there a way of determining this number? Yes. Using the change of base formula. Why would I change the base? Because the calculator, all calculators should have natural log and common log. However, this sophisticated calculator has also the option of putting in the base you want. The previous calculators that I had, they did not have that option. So let me show you the change of base, and then I'll show you with the calculator as well. So the change of base, you don't need a sophisticated calculator because we have a way of determining these. Okay, so let's say I have this log base 3 of 7, and we want to use common log. It's common log of 7 over common log of 3. Common log of the number that I want to apply log to, and the denominator is the log of the base. Let's say you don't want to use common log. Fine, you can use natural log 7 over natural log 3. Same thing, but you have to have top and bottom the same log. You can say log base 7 and common log 7 natural log 3. That's not going to work. So same logs. Both numbers will be the same because there is only one number. You understand, there is only one number that I raised 3 to get 7, not 2 different numbers. So this ratio has to give us the same answer. So let's do that first, and then I'll show you with your sophisticated calculators. Go to, no, don't do that just yet. I'm sorry. So log 7 divided by log 3. And I got 1.77 blah, blah, blah. 1.7712. If I use natural log 7 and I divide by natural log 3, I get the same thing. Same number. Same. How do I check my answer? Here's how I check my answer right here. 3 raised to this number has to equal 7. Let's check. 3 raised to, I'm going to call that number with second and answer. I want the whole number. I don't want to truncate it because I'm not going to get the exact 7. When I click enter, I have to get 7. But this sophisticated calculator has the option that if you click on math and scroll up to log base, so choose A. As you see, it pops up. It tells you, it allows you to put the base you want, and then 7. And when you press enter, you have to get the same number, 1.7712, blah, blah, blah. Don't worry. If you don't have this in math, it's okay. You can always use the formula. Any questions? Any questions? Okay, let me show one example, and then Ben, are you ready with your question?
Yeah.
Okay, I want to show 28 on page 501. And can you give me your problem now? I'm ready to copy it. So let me copy this for a second. It's log base b and x to the third y over z squared. Yes, I'm ready for your problem as well. Because if your problem is easier than this, I'll start with yours. If it's more complicated than this, then I'll start with this.
Okay, mine is more complicated. It's log base d, and then it's square root of a times b to the 7. Sorry, so b is not under the radical. My bad. Yeah, so it's only square root of a under the radical. I'm not being clear.
It's the square root of a, not b squared. Only a is under the square root.
Okay, so we have log base d of the square root of a.
Yes, and then it is b raised to the 7th power.
So it's multiplied by b to the 7th.
Yes, over c to the 8th.
Like this?
Yes, and the base is d.
Good,
Yeah.
very good.
Like
Good,
that.
good, perfect. So let's do this one first. Let me remove this. I'm hoping that someone will look at these notes, so then you don't get confused. Okay, perfect. So let me stop